Want to classify text sentiment while explicitly defining the possible outputs? You'll see how to declare a dspy.Signature with typed input and output fields, then use dspy.Predict to generate a sentiment label and confidence score from a sample sentence.
From typing, import literal. Classify dspy.Signature. Classify sentiment of a given sentence. Sentence, str equals dspy, input field. Sentiment, literal positive. Negative, neutral equals dspy, output field. Confidence, float equals dspy, output field. Classify equals dspy. Predict, classify. Classify, sentence equals, this book was super fun to read, though not the last chapter.
This demonstrates dspy's signature-based declaration pattern, where language model tasks are defined through structured class syntax instead of raw prompt strings. The code specifies a sentiment analysis task by declaring input and output fields, sentence, sentiment, confidence, within a classify class that inherits from dspy.Signature. The key distinction is how the signature class serves as a self-documenting interface definition that dspy will later use for prompt construction. The pattern works by using Python class definitions as task blueprints, where field names and type annotations provide the structure for LM interactions. When dspy.Predict classify is called with a sentence, dspy generates the appropriate prompt and parses the response according to the declared output fields, handling the conversion between Python types and natural language. This approach shifts the focus from writing prompts to defining input-output contracts through code. This matters because it replaces free-form prompt strings with explicit, maintainable code definitions. The signature pattern makes the expected inputs and outputs visible in the codebase itself, which improves clarity for tasks that need to be shared or composed. The trade-off shown here is defining behavior through code structure rather than natural language, gaining explicitness while relying on dspy's internal handling of the actual LM interaction. Let's break it down line by line.
From typing, import literal.
Imports literal to restrict the sentiment field to specific string values in type hints. This declares that only positive, negative, or neutral are valid classifications, enabling static type checkers to catch invalid assignments during development.
Classify dspy.Signature.
This defines a classify class inheriting from dspy.Signature, declaring the expected input and output fields for a sentiment classification task. The signature serves as a structured template where sentence is the input and sentiment/confidence are the declared outputs, using Python type hints for clarity.
Classify sentiment of a given sentence.
This docstring defines the tool's purpose for both developers and dspy's prompt generation. It becomes part of the instruction template that guides the language model's behavior during prediction.
Sentence, str equals dspy, input field.
This defines sentence as an input field using dspy, input field, marking it as a required string parameter for the signature. The type annotation and field wrapper enable dspy to recognize this as user-provided input during prediction calls.
Sentiment, literal positive. Negative, neutral equals dspy, output field.
This defines sentiment as a structured output field that must be one of 3 literal string values: positive, negative, or neutral. The literal type annotation declares the allowed values, while dspy, output field, designates it as a field the signature expects the model to generate.
Confidence, float equals dspy, output field.
This defines an output field named confidence that forces the model to return a floating point score. The dspy, output field, wrapper integrates it into the structured prediction signature, ensuring the field appears in every prediction result.
Classify equals dspy. Predict classify.
This instantiates a dspy predictor using the classify signature, creating a callable object that maps the defined input field, sentence, to the specified output fields, sentiment, and confidence. It bridges the declarative schema with dspy's prediction system, enabling execution via a simple function call.
Classify sentence equals, this book was super fun to read, though not the last chapter.
This executes the sentiment classifier with a sample sentence, demonstrating the signature in action. The output will include both the predicted sentiment label and confidence score as specified by the classify signature. dspy.Signature pattern. The classify signature defines a sentiment analysis task with explicit input-output fields, using literal to declare the allowed sentiment values as positive, negative, or neutral. The classify instance demonstrates how to create a predictor from the signature and invoke it directly with a sample sentence. This approach leverages Python-type hints to declare structured AI task interfaces without runtime enforcement.
The confidence that measures itself was never uncertain.